are now recording. So, all right, so we're going to start AC today. Okay, we use sine waves, but there's other types of waves. Okay, so I kind of gave you guys a little example here. Obviously, this is a sine wave. This is a square wave. You got triangle wave. You got sawtooth waves, and you got other ones, but those are your major ones. But we use the sine wave, so that's all we're going to be really worrying about when we're doing ours. We're going to say they're sine waves. Okay. Some terminology that you need to know, okay, is a cycle. A cycle is one complete evolution of its shape until it's ready to start again. Okay, so this is one cycle of a sine wave. Because as you see now, when it gets back to here, it's getting ready to start again. This would be one cycle to here of your square wave. Here, this part here, it's already started again. One cycle of a triangle wave. Then the sawtooth wave, I actually put a couple cycles up there. You can see this would be one cycle. There will be another cycle. And I got about half of a third cycle. So that's all a cycle is. It's just one complete evolution of the waveform. Okay. Period is just the time it takes to complete one cycle. So however long it took this wave to complete that one cycle, that's your period. Okay. It's usually measured in seconds. Okay. It could be milliseconds, microseconds, it can be just regular seconds, but it's something in seconds. The biggest thing we're going to be concerned with is the frequency. Okay, that's the number of cycles that it completes in a given time. The way we find it is it's 1 over the period or time, because you can say period is just the time. So, and it's measured in hertz. Okay, so you'll see it as Hz. Okay, so that's the big one we need to remember is frequency. We're going to use frequency a lot in AC. Okay, I know I took all the time to write all this up, and now I'm going to erase it all. So when we were doing DC, okay, and I told you, oh, hey, you got 10 volts, okay, that's what you had. It was just 10 volts, okay. In AC, we have more than one type of voltage. So we need to understand how to convert from one type of voltage to another to get what we want. Okay, so if I put a sine wave up here, okay, if I measure from here to here, if I measure this portion right here, that is what I call my voltage peak. Okay, it's V with a little p by it. So that's my peak voltage of that waveform. So that's one type of voltage I can have. I can have volts peak. Okay, it's P-E-A-K. Volts peak. And it's just VP. Okay, if I measure from, let's do it this over here. If I measure from there to there, okay, I get what we call voltage peak to peak. Okay, so also have voltage peak to peak. Okay, that's another one I can have. Voltage peak to peak. I can also have what we say is VRMS. Okay, and the RMS just means root mean squared. Okay, that's your DC equivalent. So when we measure our voltages with our voltmeter in the lab, the voltage we are measuring is VRMS. Okay, and if we could get into the lab, our AC generator that we got, our function generator, what we use for our AC voltage source, we can set it up in volts peak, peak to peak, and we can also put in VRMS. So we can put it in any form that we want. Okay, and what we need to learn though is how to convert from one to the other. Okay, and I'm going to take that EAK off of there because that's how we represent it. Volts peak to peak, VRMS. we need to understand how to convert from one to other. Because if I give you volts peak, I may want you to give me the peak-to-peak voltage, or I may want you to give me the VRMS voltage. So we have to learn how to do them. If I give you volts peak, the way we get peak-to-peak is we just double it, okay? If I go up 5 here, I got to go down 5 here. So if my volts peak is 5 volts, my volts peak-to-peak has to be 10 volts. Everybody see that?
Yeah.
That's all I'm doing is I'm just doubling it, okay? The way I get VRMS is equal to volts peak divided by the square root of 2. So if I want VRMS, I have to know my volts peak, and then I just divide by the square root of 2, okay? If I know peak to peak, can I get VRMS?
Divide by 2 and then.
Yes, I have to divide by 2, get my volts peak, and then divide by the square root of 2. I cannot go from peak to peak directly to VRMS, and I can't go from VRMS directly to volts peak to peak. I have to go to peak somewhere in there. So if I want volts peak and I got VRMS, volts peak is equal to VRMS times the square root of 2. Makes sense, right? If this one's divided by the square root of 2, if I multiply by the square root of 2, I get volts peak. Okay. Pretty simple, right? So far, not too hard. We're just dividing or multiplying by the square root of 2, and to get volts peak, we're just going to double it. Okay, double our volts peak. Man, we got our peak to peak. Okay, good, because we're going to try a few. So we're going to do one together, and then what I'm going to do is I am going to put something up here and let you guys do them. So what I need to know is who all do I have in here? That is the question. So I got Francisco, Michael, Nathan, Larry, Thamer, Jack, Jason, Becky, and Marcus. Okay.
I'm on muting.
So I got 1, 2, 3, 4, 5, 6, 7, 8, 9 of you guys in here. Okay. So 9. Awesome. That's just enough. Perfect. Okay. So we'll do the first one together. We'll go through it, and then I'll put some up there for all you guys. So let's say I have 5 volts peak. I want to know my peak to peak, and I want to know my VRMS. Okay. Now that we're into AC, we're going to try to go to 3 decimal places. If you go to 2, I'll take it, but 3 is just going to make us a little more accurate when we're measuring stuff, because we're going to be dealing with angles and all that good stuff in here. So how do I get my peak to peak? I double my peak. So my peak to peak is 10 volts peak to peak. Okay. How do I get my VRMS? I simply divide 5 by the square root of 2, which gives me 3.536 VRMS. So that would be my voltages. If you notice, my VRMS is always going to be my smallest voltage. My peak to peak is always going to be my biggest voltage. So when you're doing them, if you notice your VRMS is not the smallest one, you did something wrong. If your peak to peak is not the largest one, you did something wrong. Okay. So let's start with Francisco. So you got 10 volts peak. I want to know voltage peak to peak and VRMS. Okay. Then I got Mike. So you got 15 volts peak to peak, VRMS. And I got Nathan, 20 volts peak to peak, VRMS. And then I got Larry, 25 volts peak, peak to peak, VRMS. And I got, Becky, 30 volts peak, peak to peak, VRMS. I got Thamer, you got 35 volts peak, peak to peak, VRMS. I got to see who else I got here. And I got, already got Nathan, right? And I got Jack, you got 40 volts peak, peak to peak, VRMS. And I got Jason, you got 45 volts peak, peak to peak, VRMS. And Marcus, you got the last one, 50 volts peak to peak, and VRMS. So when you get your answers, let me know, and then we'll write them on the board.
Okay, I got mine.
Okay, who said they got theirs?
Me, Mike.
All right, okay, which one did you have?
I had the 15 volts.
Okay,
peak,
so what'd you get peak to peak? 30?
30 volts peak to peak.
And
the VRMS 10.606.
10.606. Okay, that looks good. So that one is correct.
All right, you ready?
Francisco, you had 10 volts, right?
Yeah, I got 10 volts, and
Okay.
the peak was 20.
And
the
VRMS?
14.142.
Are you sure? You might want to check that again. That does not become the smallest one if it's 14, right? That's bigger than 10. VRMS should always be the smallest one. Did you do 20 volts divided by square root of 2?
Did not divide it.
It should be 10 volts divided by the square root of 2. Remember, it's volts peak divided by the square root of 2.
It's 7.071.
That sounds much better.
Cheap calculator.
All right, I'm ready.
All right, who's that? Larry?
There, yeah.
Which one you got?
25 volts,
Okay, what do you got peak to peak?
50 volts,
Outstanding. And VRMS?
17.678.
Outstanding.
I got mine.
Okay, who's that?
Hammer.
Okay, which one did you have?
The 35.
35? Okay, what'd you get?
70 for peak to peak.
70 and
24.75.
outstanding.
I got mine.
Okay, who's that?
Jason,
Jason, which one did you have?
45,
45, okay, what'd you get?
90 for peak to peak,
90 and VRMS?
31.819.
31.819. Outstanding.
And then for 50, I got 100
Okay.
peak, and
You got
then
100 peak to peak and VRMS?
35.35.
35.35. Outstanding.
Oh, you said 3 decimal places, or
That's fine. I'll take 2.
so is it another 5?
Okay, another 5.
Yeah.
I got mine.
Okay, who's that?
Nate?
Nathan?
Yeah,
Which one did you have?
20.
20? All right.
Mhm. So I got 40 peak to peak,
Okay.
and then 14.142.
Outstanding. Okay, I only got 2 left.
Okay, I'm good.
Okay, what'd you get? Which one did you have?
30,
30, okay. What'd you get peak to peak?
60,
And VRMS?
21.213.
Outstanding. Okay, Jack, you're the only one left.
All right, for VP, I got 80.
80 for voltage peak to peak. And
Peak.
for your VRMS,
For VRMS, it's VP divided by
square root of 2.
yeah, square root of 2, right?
Yep. So you got your 40 divided by the square root of 2 gives you
2. Okay. So when I type in the VP divided by the square root of 2, I'm using the Casio 9860.
right. You should
And,
do shift with the X squared button. That'll give you the square root. And you just type a 2 in there. So you say 40 divided by shift the X squared button.
Shift X squared.
And you should get a little square root symbol. Just type a 2 in there and then hit
Yep.
equals.
Okay,
And what-
I got it's my calculator is reading it's 28.28 or something.
28.28.
Yeah.
Outstanding. That's exactly it. Okay. Do you think we need to go over ones going from VRMS and getting peak and peak to peak, or you guys think you can figure that one out? I'm going to give you some homework on that. I mean, we can do them if you want. All it is you're taking your VRMS and multiplying it by the square root of 2 to get your volts peak, and then you just double the volts peak to get your peak to peak. Do we need to do some of those, or are you guys good with them? I will do one. We'll do one practice, and then you let me know if you want to do some like this. I can give you guys all one, or you can just do them for homework. I'll let you guys decide after we do one together. Okay. So we're going to use 5 again, only this time we're going to change it. And instead of being 5 volts peak, we're going to have 5 VRMS. We want to know what that equals: peak and peak to peak. So I'm going to take 5 and I'm going to multiply it by the square root of 2. Okay. So if I do that, I should get 7.071 volts peak. And then I just double that and I get 14.142 volts peak to peak. Everybody sees how we do it that way.
Yep.
You just got to multiply by the square root of 2, you get your volts peak, then you just double that to get to your volts peak to peak. Okay. If you guys feel comfortable, I'm not going to put any of those on the board. You will have some homework questions that I'm going to post in. In fact, I think I might have already posted them under homework. I think I did that last night. And then you'll have plenty of practice going from volts peak to peak to peak to VRMS, and from VRMS to volts peak to peak to peak. Okay. So now another thing we need to learn is when I give you a voltage for a circuit, okay, I can now give it to you in 2 different forms. However, comma, there's only one form that it can be in for us to solve the circuit. So you need to know how to convert from one form to the other, okay? The one form we're going to have is called sinusoidal form. Okay. And what that's going to look like is it's going to look like something like this. It's going to look something like that. I'll tell you voltage equals, and I'm going to show you something like this, 20 sine omega t plus 30. Okay. This 20 is volts peak. This is my type of wave. Okay. That's just telling me I got a sine wave. This omega is equal to 2 pi times the frequency. Okay. That's going to come in handy here a little bit later. The T we're not going to worry about. That's instantaneous time. If you guys continue on to ODU or Norfolk State or wherever, you get into your 300 and 400 level classes, you're actually going to start putting a certain time on that waveform where you're going to be able to get the voltage. We're not going to worry about that here. So that's always just going to stay T. And this 30 is my angle of offset. Because remember, I told you in AC, everything has an angle, right? So that's where we're going to get our angle, okay? Unfortunately, this is not the form it has to be in to solve the circuit. So if I give it to you in this, you must convert it to the other form, which is called phasor form. Okay. Phasor form is going to look like this. It's going to be something VRMS at an angle of something. So if I give it to you in this, how do I convert volts peak to VRMS? We just did it. I divide by the square root of 2. So if I divide 20 by the square root of 2, I get 14.14 VRMS. And then I just take this angle and put it down here. Okay. The way you will see me write it, though, will be like this. I will just write it 14.14 at an angle of 30. You need to know this is phasor, which means that's my VRMS voltage. I will not write in 14.14 VRMS at an angle of 30. I'll just write 14.14, or I may even put 14.14 volts at an angle of 30. You need to understand that that's my phasor form, which means that's VRMS voltage. Okay. So if I give you sinusoidal, you got to convert it to phasor. Okay. I can also ask you to convert phasor to sinusoidal. Okay. The way I do that, I'd multiply this by the square root of 2. I get my 20. We always use a sign. So then I put sine, and then I just put parentheses omega t plus whatever my angle is here. If I have a negative angle here, then it becomes minus whatever my angle is.
Before you get too carried away, where's the omega on a calculator?
There is none.
Okay,
Trust
'cause
me.
I'm not familiar.
You're not going to solve anything with this anyway. You don't. And when you convert this to phasor, all you care about is your volts peak, put the VRMS, and you bring your angle down. That's it. The omega, I could put a number in there, and you guys are going to learn 2 pi f is going to be something that we're going to use a lot of. So if I give you something in phasor, or I mean in sinusoidal form, and I put a number in here for omega, remember that omega is equal to 2 pi f. Okay, and as we move along, which we will do here shortly, you will see where this 2 pi f comes into account. Okay, and what that is that is actually your angular velocity, but we're not going to worry about that. Okay, so if I put a number in here and I asked you for the frequency of a circuit, I would just take, let's say I put 300 as instead of omega. I just divide that by 2 pi, and that would give me the frequency of the circuit. Okay. I probably won't ask you for that, but that's how you could find the frequency. If I put a number in here for omega, I just divide it by 2 pi because omega is equal to 2 pi f. I just divide it by 2 pi. It gives me the frequency of my circuit. Okay. So let's do one for practice going from sinusoidal to phasor. Okay. So let's say I had something like this. Okay, as you see, now I put a number in there, but I'm not worried about that number right now. I'm just converting to phasor form. So how would I convert that to phasor form? Well, this 40 is what?
28.24.
Boy, it is volts peak, right? So I must divide by the square root of 2 because I know phasor is VRMS. So somebody already said it. What'd you get?
28.284.
So it'd be 28.284 volts at an angle of, what's my angle?
40.
What's that again?
40.
Negative 40.
Negative 40. Because it's a minus, so it's at an angle of negative 40. And that's how I convert it from sinusoidal to phasor. Don't worry, you'll get some practice. There's some of these converting from sinusoidal to phasor on the homework. Remember, you're not worrying about this part of the circuit, or I mean this part of the voltage or this. All you care about is this 40 volts peak and whatever my angle is to convert it to phasor. Okay? So let's do a phasor to sinusoidal. Say I had 25 volts at an angle of 30. How do I convert that to phasor? Well, this is what? That 25 is what type of voltage?
RMS.
VRMS. My sinusoidal has what type of voltage? Volts peak. How do I get from VRMS to peak?
Multiply.
Multiply by the square root of 2. So if I multiply 25 by the square root of 2, you should get 35.355. And then I put sine, because we're always going to use a sine wave, times, you don't know any numbers, so you just write omega t. It's a positive angle plus 30. And that's my sinusoidal voltage from this phasor voltage. Fairly simple stuff, right? Don't worry, you'll get practice converting those too, because they're on the test.
Yes.
Okay, so here's my question. So we're going to have now, instead of just resistors in the circuit, we're actually going to have other components in the circuit. Okay, we're going to have capacitors, which are represented by a C. Resistors were R1, R2, R3. Capacitor will be C1, C2, C3. The schematic symbol for a capacitor, you will see either something like that or something like that. Okay. These are polarized capacitors. These are non-polarized. What's the biggest difference between polarized and non-polarized that you see? The non-polarized doesn't matter which way you put it in the circuit because you got the plus and the minus on both sides. polarized, if you put it in the circuit the wrong way, it will blow up on you. Hence is why anytime we do labs in the class, you guys will use my capacitors that I give you, because the ones that I give you are non-polarized. So it doesn't matter which way you put them in the circuit, they will, it will not explode on you, okay? Capacitors are measured in farads, okay? So the most common ones you're going to see are microfarads, nanofarads, and picofarads, okay? And farads, you'll either see it F, or sometimes you'll see it FD, okay? Usually when I write it, I'll just write it with an F, but you will also see it FD sometimes, okay? So a capacitor is just two conductors insulated by an insulator. And what is a capacitor designed to do? Anybody know? Why would we put a capacitor in there?
Stabilized voltage.
We want to hold a voltage, right? Because it's going to hold a voltage, and it's not going to, it doesn't want to let any current flow through it. It just wants to hold that voltage. And then we can use that later on, where we could take away the power source and use the capacitor as the power source. Okay. So here's my question. Let's say I got a circuit that's got resistors and capacitors in it. Okay. Well, we know to find, if it's a series circuit, how do we find the total resistance in a series circuit? We just did what?
Added up.
Added up all the resistor values, right? Well, let me ask you this. How am I going to add ohms and farads? The answer is you can't. So we've got to convert the capacitor into some sort of ohms, okay? And the way we're going to do that is we're going to find what we call the capacitive reactance. Which is X of C, okay? And this will express the capacitive reactance of my capacitor, and the answer will be in ohms. Could be K ohms or whatever. X of C is equal to 1 divided by 2 pi times the frequency times the capacitance. Remember I said that 2 pi f we were going to use somewhere? Here's where we're going to use it. Okay. So if I told you you had a 1 microfarad capacitor in the circuit, and our frequency was 2 kilohertz, how would I find my X of C? I would just simply plug it in. 1 divided by 2 pi times 2 kHz times 1 microfarad, because 1 microfarad is my capacitance. And, oh, imagine that, I already have that one done up. If I do that, if I multiply all these together and then say shift reciprocal, I should get 79.577 ohms. But this is AC. What did I tell you everything needs to have in AC? Come on, don't be dead on me. Everything needs to have a what in AC? An angle. X of C, or the capacitive reactance, is always at an angle of -90 degrees. So anytime you find X of C, you're always going to put a negative 90 degrees on it. Okay? Everybody's got that. Always negative 90. So if I change this to 4 microfarads, I'd simply put a 4 here, and then I would figure that out. And if you punch all that in your calculator, somebody give me a volunteer.
How do you do the 2 pi? Because I haven't found that on the calculator.
2, and then if you got the Casio, it's 2, shift your exponent button, the little EXP button. If you hit shift EXP, that's got a little pi sign on it. So you just, if you got the Casio, it should. So you just hit 2, and then shift EXP, and it puts a little pi in there. If you can see that. Look at your EXP. It should have a little pi button, a little pi symbol on the EXP somewhere. And it should be in the same color as whatever your shift is. Like mine on this one, my shift is a gold. So the pi is in gold, so I know I got to hit shift EXP.
I don't see the pi symbol.
If you look at my EXP button, you can see the little pi symbol right there.
Mine has a, I don't have an EXP button. I have an EXE button.
Oh,
It's
no, you got the EXE button over here. You got a Casio?
yeah, I see it. Never mind. I'm retarded.
There you go. So somebody punch that in their calculator and tell me what you get for the capacitive reactance of that capacitor at a frequency of 2 kilohertz. Remember, I told you easy way is just multiply these all together, hit equals, and then hit shift reciprocal and hit equals again. That way you don't have to do 1 divided by all this. Multiply, just multiply, shift reciprocal, bam, you got your answer.
I got,
What?
hold on.
Anybody
Got
get it?
19.894.
0.894 what?
Ohms
Ohms
minus 90 degrees.
at an angle of negative 90 degrees. That is my answer. If you leave off the negative at an angle of negative 90, you're wrong. And you're going to see why you need to have that on there. Okay? So by looking at this equation right here, if I raise this frequency, what's going to happen to my X of C? Is it going to go up or is it going to go down? Just by looking at this equation, which is X of C.
Down.
If exactly, if I raise the frequency, my X of C is going to go down. So if I kept the same capacitor value, but I changed the frequency to 6 kilohertz, this is going to get even lower. Because as I make this number bigger in the denominator, that's going to make X of C go down. If I reduce the frequency, it's going to go higher. Same thing with the capacitance. The larger my capacitor, the smaller my X of C value. Because as this gets higher, this is going to go down. As my capacitance goes down, my X of C value is going to go up. Don't worry, you'll get some practice. There's some of these on the homework too. Converting and finding the X of C. I'll give you a capacitor value and a frequency, and you'll just figure it out. Okay? So, if I gave you something like this, as your voltage, and I gave you a 2 microfarad capacitor in there, and I want you to find X of C, What does x of c equal? 1 over 2 pi f times c. So in this one, x of c equals 1 over, what do I have? What do I put down here? What did we say this was equal to?
Not used.
We told you it was equal to 2 pi f, right? So this part is 300. And then I multiply it by my capacitance. Do not put the 2 pi in there. Omega, if I give you a value for omega, that is equal to 2 pi f. Omega equals 2 pi f.
Don't erase that.
Okay, so you don't have to worry about 2 pi in the frequency here. You just plug the 300 in as the 2 pi f, multiply it by my capacitor value, get my answer, and it's still ohms at an angle of negative 90. So if I'm a nice guy and I give you that, I make figuring out x of c a little bit easier. You don't have to worry about the 2 pi f because you already know the answer to the 2 pi f. It's 300. So you got to remember that. Omega is equal to 2 pi f because you might have some of those on the homework too where I give you a sinusoidal voltage. So if I give you a sinusoidal voltage and I give you a value of omega, I don't have to give you a frequency. If I give you a phasor voltage, I must give you a frequency for the circuit, or I must give you the value of x of c, or you cannot figure it out. So if you don't see a frequency, that's kind of a clue possibly that you have a sinusoidal voltage with a value for omega in there. But I could give you a sinusoidal voltage with a frequency because maybe I just say omega t and then I give you a frequency. Okay, there's some of those on the homework.
What does that actually work out to?
I don't know. Let me see. 300 times 2 micro. I got 1.667 k ohms at an angle of negative 90.
Sure, I did it right.
Yeah, that's what I got.
Yeah. You just, that's the easy way to do it. Okay, because then you don't have to worry about getting the frequency, and it's less numbers you have to punch in the calculator. Okay, so the next thing we're going to put in our circuit are these nifty little things called inductors. Okay, how do we represent an inductor? Well, I don't use I because I is what?
Current.
I is current. So they're represented by an L. And the schematic symbol, you'll see it like this, like a little coil, or a lot of times I just draw it like this. Okay, just a little, not like a resistor where a resistor goes to a point. These are humps. Okay, and an inductor does what? Anybody know? The voltage holds a charge, or the current, or your capacitor holds a charge. Your inductors they will work to keep the current constant. Okay, they want a constant current going through, and they're measured in henries. Okay, I've seen it that way or this way. I don't care which way you write it. I'm going to write it like that with an H for henries. Okay, and you'll see usually you're going to see henries, millihenries. You might see microhenries. You're probably not going to see nano or picohenries. You might. I doubt you're going to see kilohenries either. At least not with us. Okay. Okay, they oppose changes in current by developing a voltage across it proportional to the rate of change of the current. Okay, an ideal inductor would offer no resistance to the constant direct current. Okay, so it wouldn't offer no resistance, current would just constantly flow. Same thing here. How am I need it from Henry's? Add Henry's along to ohms. I can't, so I got to convert these to what we call inductive reactance. So if capacitive reactance was X of C, guess what inductive reactance is?
L of C.
X of L, because L is my inductor, so it's X of L. This one's a little bit easier. X of L is equal to 2 pi FL. No dividing, just multiply. So again, let's use our 2 kilohertz. And let's say I got a 2 Henry capacitor, or I mean inductor. I just 2 pi times 2K times 2 Henry. And if I do that out, 2 pi times 2K hertz times 2 Henrys, and I would get 25.133 K ohms. But it's AC. Everything in AC needs a what?
Angle.
An angle. And the angle on an inductor is always, always, always a positive 90 degrees. Okay. Same thing here. If I give you a sinusoidal voltage and I put a number in for omega, omega is 2 pi F. I just put that number in here and multiply it by the inductor value. I don't have to worry about my frequency. Okay. Don't worry. You will get a chance to practice some of those on the homework as well. Okay. So if I got an angle on my capacitor of what?
Negative 90.
Negative 90, and a value or an angle on my inductor of what?
Positive 90.
Positive 90. What do y'all think the angle is always, always, always on a resistor?
0.
Exactly. So the angle on my resistor is always 0. So now when you guys get a circuit, you're going to see something like this. What's this one? And you're going to see something like that. So what type of circuit do I have there?
Series.
What type of series circuit? Is it a DC series circuit? This gives it away. That is the symbol for an AC voltage source. Because remember, a DC voltage source, the symbol is what? A battery, correct?
Okay. Yeah.
So what type of voltage did I give you? What form did I give it to you in? Remember, we got 2 forms. What are my 2 forms of voltage I can give you? Man, you guys forgot this already? Sinusoidal and
We're excited from the test.
I can give it to you. I can give you sinusoidal form or what other form?
Laser.
Phasor. Which one is this one? Is this sinusoidal or is it phasor?
Phaser.
That is phasor. Okay. What form do I need to be in to solve my circuit? I need to be in phasor to solve my circuit. So this one, I'm good. I'm already in phasor. I don't have to do anything with it. Okay. The next thing when I go through these, I want to look, okay, I know I'm in phasor. So I just told you if it's in phasor, I also have to give you a what? I have to give you a frequency. So the frequency, we're going to say is 1 kHz. Okay. So if I give you phasor, I have to give you a frequency. If I don't give you a frequency, you can't solve it. Okay. So that's the first thing. First thing I'm going to look at is what type of voltage do I have? What form is it in? If it's in phasor, I'm good. If it's in sinusoidal, I got to convert it to phasor. Then I'm going to look is, okay, well, if it's in phasor, do I have a frequency? Okay, yes, I have a frequency. If it's in sinusoidal, do I have a frequency or do I have a value for omega? I need one of the two. Okay. Then I'm going to go back and I'm going to look at all my components. Are all my components in ohms? And when I look at this, my answer is going to be, are all my components in ohms?
Yep.
No. So I need to find X of L, which I know is equal to 2 pi FL, which equals 2 pi times 1K times 1 Henry. And I'm going to figure that out. So somebody figure that out and tell me what you get for X of L. And when you guys are doing these, you should write down the equations every time until you get used to them. I would write them down all the time, but if you get used to them and then you don't want to write them down, that you know them, that's fine with me. I don't care. But I would write them down every time. So somebody compute me up and tell me what you get. Come on, this is the easy one. It's all multiplication.
How about 6.283K?
6.283, whoops, 283K ohms.
With an angle of 90 degrees, minus 90 degrees.
At an angle of 90 degrees because it's an inductor. Now what I'm going to do is I'm going to go back to my circuit and I'm going to ever so gently line out that 1 Henry and I'm going to write 6.283K ohms at an angle of 90. Okay, cool. I got that. Is everything in ohms now? No. I need to find my X of C, which I know is 1 over 2 pi FC, which is equal to 1 over 2 pi times 1 kHz times 0.1 microfarad. So somebody do that up and tell me what you get for that. Other than Larry, because he gave me X of L. He was smart. He took the easy one.
Uh, 159.15 ohms.
Nope. Try again.
Damn.
You were pretty close. You have all the numbers right. They're just not they're just not at the right. I will say your decimal point is not in the right spot.
There's 1.592.
1.592. What? K ohms. What else do I need?
Angle 90 negative.
Angle of negative 90 degrees. So then I'm going to ever so gently line that out, and I'm going to put 1.592 K ohms at an angle of negative 90 degrees. So now is everything in ohms? Yes. Does everything have an angle on it?
Yes.
No, it doesn't. I didn't put an angle on my resistor yet. What's the angle on my resistor?
0.
0. Okay, so now does everything have an angle on it? Yes, it does. Okay. Here is the only thing that's going to change between DC and AC. In DC, we added up all the resistor values and we got the total resistance, right? In AC, we're not getting a resistance. We're getting what we call impedance. So Ohm's law will change a little bit. Instead of being E over IR, it's now E over IZ. Z is your impedance, because we can't say it's resistance because we're finding a capacitive and an inductive reactance. So it's an impedance. So we're going to find our total impedance. Okay. And since my board is small and I'm running out of room, I'm going to erase these equations so that way we can have some more room to work, since we figured those out already. So I want to find my Z total. Well, how do I find Z total? I say it's R1 plus X of L1 plus X of C2. I'm just going to add them all up. So I got 100 ohms at an angle of 0 plus 6.283 K ohms at an angle of 90 plus 1.592 K ohms at an angle of negative 90. So my Z total is going to equal, and you guys are going to get this as soon as I show you how to set up your calculator to add angles. So if you've got the Casio calculator, if you do not, I do not know how to tell you to set it up to add angles. So if you get the Casio calculator, get your screen up just like this, like you're ready to add something or multiply something, and hit Shift Menu. And you should get a screen something like that, if you can see it. Get your input, your mode, all that should come up. Okay. Everybody's got that screen.
Yep.
Okay. Use your little down arrow, and I want you to go down to where it says angle. Make sure it says degrees. If it does not, press F1 for degree. Okay. So everybody's got it, got their angle now in degrees, right?
Yep.
Okay. Scroll down one more to where you see complex mode. And all your guys' probably says real right now, right?
Yes.
You're going to push F3 so it says R theta, just like mine does. R theta. Everybody's got it in R theta now. Then go down, scroll all the way down till you see display, and just make sure it still says normal 1/E for engineering. And if it does, hit your execute button and bingo, you're good. You'll go back to this screen once you hit the execute button. Okay. Now, the only problem you're going to have is if you use this calculator for a math class, you're either going to have to go back and put that complex mode in real, or when you do something like, let's say we did 9 minus 12, and we know our answer should be what? 9 minus 12 is?
3.
Negative 3. I'm going to get an answer like that. It says 3 at an angle of 180. That just means it's a negative 3. So you either have to go back and change it or just use a different calculator. I would recommend you use a different calculator and keep this one set up. So now what you're going to do is you're going to type in 100 for your resistor, and then you're going to hit your shift button, and then 2 below the shift button, you should see this button with a X, a theta, and a T on it. And if you look right above it, you should see the little angle symbol. So you're going to hit that button, and it should give you something like that on your calculator. And then you're just going to type a 0 in there for angle of 0. So you should have something just like that on your calculator. Has everybody got it?
Yep.
And you're just going to hit plus, and then you hit 6.283 exponent 3 because it's K ohms. And then I'm going to hit that shift angle button again, and I'm going to put 90 in there. And then I'm going to hit plus again, 1.592 exponent 3 because it's K. Shift my angle button. Now do not hit the minus sign. Hit your negative sign. That should be next to your EXP button. Negative 90. And then I'm going to hit equals. So somebody tell me when you hit equals, what did you get?
Really long string of numbers.
So we're going to go to 3 decimal places. So if I go to 3 decimal places, what do I get? You should get 4.692, and that's going to be K ohms at an angle of 88.779 because it's 87, so that 8 would change to a 9. So that is my Z total. Now, before you do anything, everybody's got this little arrow button over here on the side of their computer or their calculator, right? Hit that little angle button, and you should get a thing that has answer with an arrow, right? Then you're going to hit the alpha button, which I think is right below your shift button, and then go down to where I think it's your 0. There should be a Z on there. It is, so it says like mine, answer with the arrow and then the Z, and then hit your execute button, and it's going to put it in there. What you just did is you just stored your Z total in the Z button on your calculator. And the reason I told you to do that is because that's going to make it easier for you, because now we're going to find I total. Well, we know I total is what? E total divided by Z total. Okay, so what's my E total? 100 at an angle 0. So I'm going to type 100, shift, angle, 0. So you should have something like that. If you can see my calculator, trying to get it. And I'm going to hit divided by, and then I'm going to hit alpha Z. So now it just put my Z total. I'm dividing by my Z total, and I'm going to hit equals, and somebody tell me what you got for I total. This is where you're going to have to know how to move your decimal places now. It's not going to give you milli and all that. So when you do it, you should get 21.313 milliamps at an angle of negative 88.779. Is that what everybody got on their calculator? Because you get 0.0213125.7 and an angle negative 88.7787.
I get a little lost in the calculator thing when we were programming it there.
Oh,
Not
okay.
the programming, but when we put the answer, the ANS.
Okay. So do you have just the ANS on there with the arrow? Or no? Or do you just have your Z total up there right now?
What is your model calculator again?
I got the CG10. So mine's color. It's got a little backlight. Okay. So,
Yeah, well, I just deleted everything back.
okay. So let's do our Z total again, and I'll show you how to store it. Okay. So we want 100, shift our little angle button 0 plus 6.283 exponent 3, shift our angle button 90 plus 1.592 exponent 3, shift our angle button, hit our little negative sign, negative 90, and hit equals. So you should have something like that on your calculator right now. I know it's kind of hard to see mine.
That's not what you wrote.
Well, I made it 4.9692K. I moved my decimal point over 3 and just wrote it as 4.692 K ohms. Okay. So then you should have a little arrow key like right here. It should just be an arrow pointing to the right. Hit that and you should get answer with an arrow. Then hit alpha and 0 should be your Z. And it'll put a Z in there. And then once you got that, you just hit execute and it'll put your Z total back up there again, but it stored it in your Z key. And then when you do I total, you just type in your 100, shift, angle, 0, which is your E total. Okay. And then divide by, and then just hit alpha Z again. And it should give you something like that, 100 and an angle of 0 divided by Z. And then hit equals, and it gives me my I total. And if you want to, you can then store your I total the same way. Just hit the arrow, then hit alpha, and what I do is I find the I key, which mine is the open parentheses, I, and hit equals, and now it's stored my I total under the I key. So I can use that when I go, because I'm going to go back and find all the voltage drops. Or I can use my voltage divider rule, which is what I like to use. So I'm going to put 100 at an angle of 0 times, I'm going to do my resistor, 100. Oh, God darn, I cleared everything. 100 at an angle of 0 times 100 at an angle of 0 divided by, and I'm going to hit alpha Z because I want to divide it by my Z total and hit equals. So VR1, I got 2.131 volts at an angle of negative 88.779. So that's my voltage drop across my resistor. And then I'm going to do the same thing for the rest of them. Again, 100 at an angle of 0 times 6.283K at an angle of 90 divided by alpha Z. And when I do that, I get 133.907 volts at an angle of 1.221. So that's my voltage drop there. I'm going to do the same thing for my capacitor. 100 angle 0 times 1.592 K at an angle of negative 90 divided by alpha Z. And when I do that, I'm going to get 33.930 volts at an angle of negative 178.779. Bingo. So that's what I get for my voltage drops. Well, how do I know those voltage drops are right? How do we know they were right in DC? We did what?
Add them all.
We added them up and they had to equal my E total, right? Well, what's my E total? 100 volts.
Oh,
Wait a minute, I got 133 volts right here. What's the deal? I don't know. Add them up and see what you get. Add up exactly what I have on the board for the voltage drops and tell me what you get when you add them up.
Do you add those up factoring the angles?
Yes. You must add them up with the angles on them. So it's going to be 2.131 at an angle negative 88.779 plus 133.907 at an angle 1.221 plus 33.930 at an angle negative 178.779. And did somebody add them up?
I'm
Or are you
working
still punching them in? So then, once somebody gets it, tell me what your calculator says.
$99.99.
99.9997.
97.
Okay, what's your angle?
Negative 6.905.
905. Is there anything at the end of that angle?
Oh. So we got
Doesn't say exponent negative 5.
Yeah.
So it says that, right? 99.997, and your angle is negative 6.905, E negative 5.
Yes.
Is that not 100?
Pretty much.
Isn't that, if I do my negative 5, means I need to move my decimal point 1, 2, 3, 4, 5, put it here, 1, 2, 3. Isn't that pretty much 0?
Yeah.
yeah.
So the angles make a difference. These are not going to be as easy as DC, where you can look at it and go, oh, yeah, they all add up. These you're actually going to have to punch them in your calculator and add them up to make sure they're correct. Because you're going to get things like this. This is 133 volts, but because of the angles on these, when you add them up, it still comes out to 100 at an angle of 0. So you just got to pay attention, because sometimes when you add them up, you're going to get something like this, negative 6.905, E negative 5. You just have to make sure you look at the angle good, which that's pretty much 0. So it definitely works out. So pretty fun and easy, right?
No.
Little more difficult because you got to put the angles on it, but using the calculator makes it a little bit easier to do.
So that Z total and the I total that we stored, will they kind of hose
It'll
us up?
it'll stay in there until you store something else in there.
Okay.
Okay, so if you do another problem, which we're going to do now, and you find your Z total and you store and you hit store alpha Z, it's going to put your new Z total in alpha Z. It'll get rid of the other one and store the new one there. So you don't have to go back and clear it out. It'll keep it there until you store something else under there. So I'm going to let you guys try this one on your own, if I could find what I did with my marker, which I found. Mm. So I want you to get Z total, I total, VR1, VL1, and VC1. So you guys go ahead and figure those out, and we'll see what we get. Remember how I told you to go through step by step. First, second, third. So I'll give you guys a few minutes to work on that.
Is that a Pico?
Did somebody ask a question?
Yeah, is that a Pico?
That is a Pico. I was muted. I thought I heard somebody. I didn't think you guys wanted to hear me go to the bathroom. So yes, Pico. What is Pico?
-9, I think.
Close but no cigar. Try again. -9 is what? Nano.
-9 is nano. -12.
-12 is Pico. Outstanding. So once you guys are done, just kind of let me know that you're done. Don't give me no answers. We'll let everybody kind of work it out. That way I just know who's done and who's not. And there should be 2 homeworks. I'll verify once we get off of here. What I want you guys to do is start working those 2 homeworks. If you don't get them all done by Thursday, don't worry about it. We'll go over. Try to have at least the first one done. That's the converting from peak to peak to peak to VRMS, peak to peak, going from sinusoidal to phasor, getting X of C, X of L. And then the second one is actually some series circuits to work. But if you don't have the series circuits done by Thursday, that's fine. But at least have the first sheet done, and we'll go over that one on Thursday. And then we'll do some more, because this is the last thing I'm going to have you guys do today. And then we'll go over some more of these on Thursday, and we'll probably get into parallel circuits on Thursday, provided you guys are getting the series pretty good, which aren't difficult. They're pretty simple. And then we'll get into some parallel circuits. And then the next thing after that, we'll get into some series parallel. And we'll be almost done. And then we'll start working. And same thing here, if you guys want, you can print out the practice test now. You can print them both out, there's 2 of them. And just work the problems that you know how to do until we get to the next ones. That way you're a little step ahead of the game. Because we don't really have a whole lot of time left in the semester, believe it or not. Because the semester is over May 11th, I believe. If I am correct. So that gives us 1, 2, 3, basically 4 weeks from today. I plan on being done. That's May 5th. So we got to get through parallel, series parallel, and then we got to do capacitors. Just capacitors in a circuit. So that, and then get time to do some good review before the test, because your final test is going to have all of this AC stuff on it, plus it's going to have a couple of DC problems on it, just so I can make sure you remember how to do DC, because those of you guys that are taking 113 in the fall, that is DC fundamentals. So you need to know your DC stuff. The good thing is you're going to have me, and I'm going to teach you some new ways to solve problems that are going to be a little bit easier than doing them the way we were doing them with series parallel. We're not going to have to compress them all the way down to a simple series or a simple parallel circuit. We're going to solve them the way they are. So it will be a little bit easier. And for those of you guys that were not here at before 4:30, I told everybody, if you take 113 in the fall with me, I am going to try to incorporate the O-scope labs from this class into 113, just to kind of familiarize you with the O-scope a little bit, because you're going to definitely be using it when you do 148 and 114. So I want to get you a little familiar with the O-scope. So since we didn't get to do those labs because we're out of the classroom now, I'm going to try to incorporate them into the 113 fall class for you guys that didn't get a chance to do them. That way you just familiarize yourself a little bit with the O-scope. And right now, the schedule is to start with remote teaching in the summertime if you guys plan on taking summer classes.
Definitely not with remote teaching.
They are they're expecting us to be back in the classroom. They just don't know when. So right now they're saying the plan is to start with remote teaching. I mean, that could change, you know, by the middle of next month when it starts, all this could be over and we could be back in the classroom. Who knows? But right now they're projecting the beginning of July to be back in the classroom, but I don't know. Yeah, if you guys are like me, I don't really care for this remote teaching. I'd much rather be in the classroom. I mean, I'll do this only because I don't want to see you guys. Guys, we already did like half the semester. I'd hate to see you guys get out and have to redo this class when you already had half of it done. But make sure when you get your voltages, make sure you check them to make sure you have the correct voltage. So let's see. Let's pick somebody. You know, we'll wait. We'll wait till some of you guys get done. Anybody done yet?
I don't even know where to start. I'm looking at the example from before this, and I just
This one's a little bit different. So he doesn't know where to start. So what was the first thing I told you to look at? When you do these circuits, the first thing I told you to look at is what? My voltage source, right? So what form of voltage did I give you here?
It's AC.
What form is this in?
Sine wave.
It's in sinusoidal form. Can I solve my circuit with it in sinusoidal form?
I need to go to the
I cannot. I need to go to what? Phasor. So how do I convert sinusoidal to phasor? Well, what's that 6? That 6 tells me it's what? What type of voltage? Volts peak to peak, or VRMS? That 6 is volts peak. Okay. So, and my phasor is what? VRMS, right? So how do I get from peak to VRMS?
You divide square root of 2.
Divide by the square root of 2. So if I divide 6 by the square root of 2, what do I get?
3 point something.
I beg to differ.
4.234. I'm sorry.
4.243 volts. And what's my angle? 60. So now I have my phasor voltage and I can solve my equation or my circuit that way. What was the next thing I told you to look at? Now that I know I've got my phasor voltage, I'm good there. The next thing I said is look and make sure everything is in what? Ohms. Is everything in ohms?
Negativo.
It is not. My inductor is in henries and my capacitor is in farads. So it's not in ohms. I have to find what? X of L and X of C. How do I find X of L? X of L equals what? 2 pi FL. X of C equals what? 1 divided by 2 pi FC. Okay. So now I need to go and I need to start plugging numbers in to my equations to get my values here. But I gave you what? What does this represent?
IF.
Omega, right? What does omega equal?
2 pi.
2 pi f. So I'm going to plug this number in both of these equations for 2 pi f, and then I'm going to multiply by my inductor here and my capacitor value here, only here, then I'm going to take the reciprocal of that number. So I don't have to worry about the frequency because I gave you omega, which is 2 pi f. And I get my x of L and my x of C values. Now, once I get those, then I have everything in ohms. Remember to have all my angles on it. And my angle on a resistor is always what?
0.
0. My angle on an inductor is always what?
90.
90. My angle on a capacitor is always what?
90.
Not negative 90. Not capacitor is always negative 90. My inductor is always 90. And then I'll have everything in ohms. I'll have angles on everything. Then I can add them up to get my Z total. Then I can get my I total. And then you can either use I times the impedance to get my voltage drop, or I can use the voltage divider rule. I like the voltage divider rule. That's just me. You guys can use whichever way you like. But remember, when I use the voltage divider rule, my voltage is not the 6, it's the 4.243 because I have to use my phasor voltage. That help you out, Jason?
Not really. It's too fast. I'm gonna have to rewatch the video and try to
That's
figure
why I'm recording it, so you guys can go back and watch it. You can pause it. You can rewind. I think it's going to make it a little bit easier for you, so you can just keep going back and watching it until you get it down. Also, watch the videos that we have in there. I think there are some, I don't know, I'm going to have to look and see if there's any on AC. If not, I know Dawn did up a few more for AC series parallel. I don't know if there's any for AC series or AC parallel. If there's not, maybe I'll pull up Zoom here one of these days and do a couple of them on the board here just so you guys can have some more videos to watch. Because videos are a great thing because you can pause, rewind, you can take your time and look at it. I know this isn't as good as being in the classroom. Because in the classroom, I can see all your faces, so then I know if somebody's not getting it. Here, it's kind of hard. So then I can stop and go back here. It's kind of hard to see your faces.
It's going to take time to get the formulas then. That's what it is.
Well, yeah, you got new formulas, so it's going to take some time to get them down. But what I'll do is I'll put up a step process here when we're done with this one on how to go through them. Maybe that'll help, and then you can just rewatch it and kind of look at how to go through it step by step. That'll help, I think, help you out a little bit. Because when you get to 113, everything we do is pretty much, there's rules and steps for everything. And if you follow the rules and the steps, they're very easy to do.
Yeah, I made it to Z total. Can we send it to you to see if it's right or not before I go any further?
Sure, if you want. You can, once you get your Z total, if you want to text me what you got or snap a picture of your calculator and send it to me, that's fine. I can do that. Just text it to me and I'll tell you if you're right or not.
How about that?
Where'd you send it? Did you
I
put it
sent
in?
Chat through the Zoom chat under your name.
No, you put it in the Zoom chat. That, let me see. Where's my Z total at? Hang on. That is correct.
Okay, thanks.
The only thing I would do is I wouldn't write your ohms like that, if you know what I mean.
Yeah, I was just trying to get it
But
trained.
yeah, that is correct. So I thought you were just gonna snap a picture of it and text it to me. What are you saying? No, Francisco. Henry says X of L. Capacitors are X of C, not S of C. One's X of L, one is X of C. Just like this, X of C, X of L. Dang, Becky, your thing flipped on me. Yeah, but I need a unit on that.
I know.
The numbers are right depending on what unit you put on it. The angle is right,
Okay.
but I don't know what units it are, what it is, because you didn't put it on there. So depending on what units you tell me, depends on whether or not it's right or not.
Milliamps.
Milliamps, what are you finding? You're finding impedance, which is in what? I just sent you. I need a calculatro. What's a calculatro? So go buy one. I mean, I don't know what you want me to do. It's not like I can send you one through the computer. I mean, I wish I could, but I can't. Has anyone finished yet? Or think they're finished?
I'm lost.
I put something wrong because I'm getting.
You're lost. Who is that said they're lost?
Mike.
Okay. Well, once we get through here, we'll go through. Did you understand what I did there where I told you first you had to find your phasor voltage?
Yeah, I got that.
Okay. And then you had to put everything in ohms. So you had to find your X of C and your X of L. Did you get that?
That's where I'm getting hung up at.
Okay. So for my X of L, I need my frequency and my inductor value. Well, I know my inductor value, 0.1. I don't have a frequency, but I gave you what? I gave you omega, which is equal to 2 pi f. So I just take this 20,000 and plug it in for 2 pi f. So I just say 20,000 times 0.1 equals. And that gives me my X of L value, which you should have gotten 2 k ohms at an angle of 90 for your X of L. Did everybody get that for your X of L?
I just did.
Okay. Is there anybody that did not get 2 k ohm at an angle of 90 for your X of L?
Go ahead.
Okay. So Then what I would do is I just line that out. This is 2 K ohms at an angle of 90. And then I do the same thing here. I just take 20,000, that's my 2 pi f, multiply by 8,200 pico, and then I got to take the reciprocal of that. I just say 20K times 8,200 exponent negative 12 equals, and then shift reciprocal equals, and you should get 6.098 K ohms at an angle of negative 90. So everybody, if you did not get that, punch that in the calculator and make sure you get 6.098 K ohms at an angle of negative 90. Like I said, 20,000, which is your 2 pi f, times 8,200 pico. So 20 exponent 3 times 8,200 exponent negative 12 equals, and then your shift reciprocal. So is there anybody that did not get 6.098 K ohms at an angle of 90, negative 90, I mean. So everybody's got that. So now I looked, is everything in ohm? Who said no?
No, I said that's where I'm at.
Okay, so you got this now, and you got
Yeah.
that. Okay, so now I say, is everything in ohms? Yes. Does everything have an angle? Yes. Okay, now I can find my Z total. How do I find Z total in a series circuit? I just add them up. So I go in, I put 1.2 exponent 3, and then I hit my shift little angle button, put a 0 in there, plus 2 exponent 3, shift angle 90, plus 6.098 exponent 3, shift negative 90, and I hit equals. And I should get my Z total. And then if I hit that little arrow key after I got my equals, arrow alpha Z, it'll store my Z total in the Z button. So when I did that and I punched it in, I got I got 4.270 K ohms at an angle of negative 73.679. If you are off by a little bit on the angle or the ohms, that's fine. You know, if you got 4.268 K ohms at an angle of negative 73.676, that's fine. You're close. Okay. A lot of it's going to depend how much you round it up here. If you went to 3 decimal places like I did, then you should get what I got. So did everybody get that for their Z total?
Yeah, I got it.
4.27K at an angle negative 73.679. So now you've got your Z total saved. How do I find I total?
How'd you save it again?
Hit the arrow, which should be right above your clear button. There's a little arrow points to the right. Hit the arrow and then alpha Z. Right after you hit equals to find it. If you did anything else, it's not going to do it. But as long as you haven't done anything else on your calculator, because you should get, when you hit the arrow, you should get it should say answer with an arrow
Yeah, I
after
got
it. And then hit alpha Z and hit execute, and it'll store it in there. And then the way I find I total is E total divided by Z total. So I just put 4.243 at an angle of 60 divided by alpha Z, and it should give me my I total. And you should get a pretty small I total. So when you
really small I total.
So when you did I total, I got 993.658 microamps at an angle of 133.679. That's what I got. You should get something pretty close to that. If you put 0.993 milliamps, I'll take it. I'd rather you do 993.658 just because it gives us more numbers and put it in microamps. But if you put it in milliamps, that's fine. Because remember, with AC, because we're dealing with angles and everything, the more numbers I have, the more accurate I'm going to be when I add these up and try to get back to my E total and all that. So
why,
everybody got that for I total.
why did you go to micro again?
Because
I have that answer and I have the angle.
it should have came out, probably when you did it, it came out like 0.993 or something like that,
Mine
milli, or
mine came-
0.0093, or you came out at 9.9365 exponent negative 4, something
Yeah.
like that. So instead of going one to the left and making it 0.993 negative 3, which would be milliamp, I went 2 to the right and made it 993.658 micro. Because if I go 2 to the right, that makes it an exponent negative 6, which is micro. Because we don't do with negative 4s, negative 5. Remember, it's always got to be something that's divisible by 3, negative 6, negative 9, 3, 6, 9, something like that. We don't do 4, 5, 7. We don't do those kind of exponents. So I have to move my decimal point one way or the other to get to a multiple of 3. So when it comes up like that, I always like to go to micro, just because it gives me more numbers. Because I'm going to be more accurate saying 993.658 micro than I would be 0.994 milli. So everybody kicking pretty good so far, right? Everybody's getting these. Now it's either voltage divider rule or I times your impedance will give you your voltage drop, whichever way you want. Like I said, personally, I like the voltage for VR1, for VL1, VC1. You can do I times 1.2K, I times 2K at an angle 90, I times this, or you can do the voltage divider rule. Voltage times this divided by Z total, voltage times this divided by Z total, voltage times this divided by Z total. Whichever one you want to use. I personally like the voltage divider rule. If you guys like using Ohm's law and doing I times your impedance, that's fine too.
Yeah, that's what I was doing. I stored the I total and then
Right.
multiplied it.
Exactly. You can do it either way. I don't care which way you do it. Numbers might vary just a little bit if you don't, from mine, if you don't use a voltage divider rule, because I use a voltage divider rule, depending on how many numbers you went out to. If you're storing it in there as the whole number, you're going to be a little bit more accurate. I stored Z total in there and used the whole Z total. I didn't use 4.270K. I just stored it and then said my voltage times my impedance divided by my Z total. So I got 1.192 volts at an angle of 133.679. That's what I got for VR1. Did everybody get something close to that?
That's exactly what I got.
So if you got exactly that or something very close to that, then you are doing it right. Did anybody not get anything close to that?
I didn't. I'm not even sure how to do it. I'm looking at the example and I don't know what I did to get there.
Okay, so
Like the
when we're
example.
finding voltage, we're doing it the same way we did in DC. I either got to use Ohm's law, take I times each one of your ohm values to get the voltage, or I use the voltage divider rule. E total times whichever one I'm trying to find divided by Z total. Same way as I did in DC. The only difference is I got angles on everything. So I got to make sure I put all the angles on everything. You can do it whichever way you want. Like Mike said, he did the I total because it's a series circuit. So what's constant in a series circuit? Current. So that current is going to go through all those different components that we have there. So I use that current, or I use the voltage divider rule. Whichever way you want to do it is completely up to you. Just remember, these in ohms now are considered your Z values, okay? Instead of R, they're considered your impedance values, Z. So it's the same way we did I times Z equals E. So I take I total times each individual Z value, and that will give me the voltage drop across each individual component. So
Okay, I got the whole thing now.
VL1, I got 1.987 volts at an angle of negative 136.321.
How'd
So
you
you,
get?
so you should have got something close to that.
I got 9.936
Uh-oh.
with an angle of 133.679 with a.
Who-
I mean, the I
who-
was stored, so I didn't type it wrong.
Who is that speaking?
Jason,
Did you use 2K ohms at an angle of 90?
I did not.
2K ohms at an angle of 90 times your I, and you should get that.
Where did the 2K ohms with an angle of 90 come from?
That's where you found X of L. Because we can't use the Henry, we got to find the X of L value, which when we put 20,000 times 0.1, it came out to 2K ohms at an angle of 90. Because I had to find these X of L and X of C so I could get Z total.
I wrote them down. I just didn't transfer the number. So
See, that's why I told you, line it out, put it up there. That way when you're doing it, you see it. So use your 2K ohm at an angle of 90 and multiply that by your I total, see what you get. Should get something pretty close to that. So we'll wait and see if Jason gets it. I want to make sure he's got it before we move on.
– 1.987 with an angle of negative 136.321.
Outstanding. And then remember for VC1, you got to use the 6.098K at an angle of negative 90. So for this one, I got 6.059 volts at an angle of 43.679. So everybody got something pretty close to that.
Got those exact numbers on that on mine.
Then what you would do is add all three of these up and make sure you get 4.243 at an angle of 60 to make sure that they're correct. So what I'm going to do now is I'm going to try to give you some steps to figure these out. Maybe this will help you. And when you're going through them, if you follow the steps, and if you want, you guys can write these down. That way when you're going through, you don't have to wait till the end of the lecture to get the steps. So step 1,
Funny, that's exactly what I did.
make sure voltage is in phasor form. Okay, so step 1, you want to look at your voltage and make sure it's in phasor form. If it's not, if it's in sinusoidal, you need to convert it. So make sure it's in phasor form, convert if necessary. Okay, so if it's in sinusoidal, convert it to phasor. Step 2, make sure you have a frequency or value for omega. So you want to make sure you have a frequency or you have a value for omega. You need one of the two. If you have the value for omega, you don't need the frequency because, I'm even going to write it in. Remember, omega is equal to 2 pi f. Okay. Step 3, ensure every component is in ohms with an angle. Step 4, find x of c and x of L if necessary. And I say if necessary because if I put a capacitor in there and say, and I put a value on the capacitor of 1 k ohm, what did I just give you? I just gave you x of c because I put it in ohms. You just need to put the angle on it. And we know capacitors always have an angle of -90. So if I give you ohms, you just put a -90 or a 90 on it, just like you do with the resistor, you put a 0 on it. Okay. Step 5, find Z total. Step 6, find I total. Step 7, find voltage drops. And there you go. So there you go. If you followed those 7 steps, you'll be fine. So first thing you want to check is your voltage. Make sure it's in phasor. If not, convert it. Then make sure you have either a frequency or a value for omega. Then ensure all your components are in ohms with an angle. If not, find x of c and x of L. Then find your Z total, find your I total, find your voltage drops. Now remember, the voltage drops you can find using Ohm's law or using your voltage divider rule, whichever you prefer. It's up to you.